Once we've collected our data, it comes time to start to analyze it. And a good way to do that is just to look at everything that you have. Now for this, we're looking at real-world data, or real samples that we collected from a beach, and we've already cleaned. It's sometimes a little overwhelming to know what to do with your data at this stage. It's often good just to start grabbing it and examining it. If your data's analog like these shells, that means looking at the real specimens and trying to get a sense of it, or at least get a big picture overview. If your data is digital, then that means doing the same process but in a digital platform, something like maybe Excel or Google Sheets, which we'll see in just a moment. What I'm doing here though is I'm just trying to get a sense of the different features or dimensions of my data that might help me think about how to classify it or categorize it. And at this stage, I don't really know much about shells, but as a human, I can look at this data and I can start to see some very clear patterns emerge. And within just a few short seconds, I'm able to classify my data really into 4 distinguishable groups, which I can draw circles around right now. And when we start to see groups of our data, a good way to think about this is as potential factor or categorical data, which we'll talk about more in just a second. But for right now, I'm just looking at these 4 classes. With a little bit of research, I'll also know that these classes actually have distinctions amongst them. If we look here, we can notice the texture on these 2 shells is a little bit different. And likewise, these taller shells, although similar in cylindrical nature, also have distinct characteristics that make them unique. I know that these top shells fall under a category known as gastropods. These are shells that are cylindrical in nature whose occupants go inside of them, inside of the cylinder. On the bottom, my 2 different classes fall under a category known as bivalves, which are 2-sided shells, oftentimes the homes of things like clams and mollusks. When I break down each individual shell, I start to think about other kinds of data or features that I can assign to each of these shells. Things like height and width are very important probably for classification, as is the weight of each shell. When I break down these categories that I've found so far, or these features, I really have a few. I've got height, which is going to be numerical. I have width, which is also going to be numerical, and I have weight, which is also going to be numerical. But I have 2 categorical or factor fields. One of them is type, and my types are going to correspond to really one of 4 categories. 1, 2, 3, or 4. And then I have another category which I can call category, and this is going to be either gastropod or bivalve. And this is going to allow for me to classify my data with these 5 different features. Once we've figured out the features that we want to identify in our data and we want to input, it comes time to actually input the data in some kind of framework. For the purpose of doing data entry, I've elected to use Google Sheets. Now there's a couple different reasons for this choice. First of all, Google Sheets provides a familiar framework for working with tabular data, or data that can be found and accessed and manipulated inside of a spreadsheet, which is what we're seeing right here. Second, it's open access and free to anyone who makes a free Google account, which means it's optimal to provide students who might not always have access to things like Microsoft Excel, which are paid software. And then finally, we have the ability to click File and Download, and we can download our data as a CSV file or a comma-separated value file. This is the main data format for transmitting data and working with it inside of R and usually Python as well. All of these reasons make it an ideal thing to choose. So the first thing that you're going to do when you're working on data entry is you're going to think about the field names or the column names that you want to select. And we're going to input these in the first row. So we are going to have a feature of height, but we're going to follow the principles of tidy data, which means we're not just going to have height, but we're also going to have height underscore mm, which conveys millimeters, or the units by which height is measured. Likewise, we are going to do this with width as well. Remember, when creating feature names, be as explicit as possible. Include both a very clear name that describes what it's measuring or what the feature is, and if necessary, include a unit by which that is being measured. It is always good to be explicit in both of these areas. And with weight, we are going to specify that we are measuring it in grams. Now we have two other features that we are working with. We are going to be working with something that we're calling type and something that we are calling category. Now here is a great tip. When inputting data, it is very easy to accidentally input wrong types of data, especially when you're working with categories. It's very easy to have typographical errors, or maybe introduce a misspelling, or maybe have something that's plural that should be singular. So go ahead and save yourself some time and headache and rectify this issue in the beginning when designing your spreadsheet for data entry. Let's use the Insert button and go down to Dropdown. This is going to create for us a drop-down menu that is going to allow us to make sure that when users are inputting data, it corresponds to a very specific schema. When we use the word schema, what we're talking about is something like what we see over here. Now, remember for type, we have 4 different categories: 1, 2, 3, and 4. So our schema looks something like this. Type will always belong to one of these 4 different categories. We don't want typographical errors where somebody can accidentally input 11, which doesn't exist as a category type. Likewise, for category, we're going to do the exact same thing. We're going to go down, select the drop-down menu, and we're going to go ahead and type in our 2 different kinds of categories. Gastropod and bivalve. This is going to ensure, once again, that people aren't inputting accidentally gastropods and bivalves, rather they're sticking to a very singular naming convention. And most importantly, we don't have to worry about anyone who's inputting data to make typographical errors, because they have the ability to select from these drop-down menus, not input the data manually. To make it a little easier for inputting data, we can also color coordinate our data. For those who have the ability to see between these different color distinctions, this makes for a convenient way to quickly and manually validate anything that has been inputted in these areas. Likewise, we can do that for our other schema here by going back and clicking the Edit button and selecting colors that are unique to each individual category. And so I'm just selecting a couple of these category colors right out of the box. Once I'm ready, I can hit Done. And at this stage, I can go ahead and drag these down so that other individuals can input new data into each of these different columns. But now I have the ability to begin inputting manually my data, which means I can specify different heights, different widths, and we can specify different grams of weight and go ahead and select specific categories for each of these different areas and input each of our data on a unique row. When working in a spreadsheet, it's important to remember that this is a CSV file data structure, which means that each row that comes after our first row is going to be a line or a sequence of data that corresponds to a particular thing. In this case, we're working with shells, so that means that each row in our data set is going to be represented by all the different features of a given shell, and we'll keep on going down and input all of that data. Once we have all of that data inputted, then comes the fun time of actually working with that data and analyzing it. To do that, we're probably going to want to use a programming language like Python or R. So stick around for the rest of this course as we dive into the programming language of R and learn how to begin analyzing and visualizing our data.